Hey, this is the PowerWeb Institute. Today, we're going to be talking about system integration. What is it, and why do we need it in the energy transition? By 2050, in Europe and here in the Netherlands, we are aiming for full carbon neutrality. That means that any remaining greenhouse gas emissions will be offset by carbon removal, so that our net emissions will be zero. And because of that, more and more of what we use, from our cars to heating our homes, will phase out fossil fuels in favor of electricity. This means electricity demand will go up. But where will we get all that electricity? One source is renewable energy, like wind and solar panels, like the ones you see over here. And these also offer us a ticket to get off fossil fuels. All this sounds great. We're reducing reliance on fossil fuels, which will make our planet healthier. But there's a challenge. Our electricity grid was never built for this kind of load. Let's look at why this is the case. When the grid was designed, electricity was only a part of our energy consumption. Heating came from gas, cars went on petrol, and industry used a mix of fuels. Now, as we electrify heating, transport, and more, the amount of electricity flowing through our infrastructure has increased. All that electricity has to flow through the same cables, transformers, and substations. Because these weren't built to carry that much power at once, they can get overloaded at moments of peak demand or generation and result in what is termed grid congestion. We can think of it this way. It's like trying to force all the water from your neighborhood through a single garden hose. Pressure builds, it stops up, maybe even breaks. There needs to be a better way to handle this flow of electricity. There's also another issue. Renewable energy is not always there. There's no sun at night, for example, and the availability of wind varies. This makes balancing how much power we generate and use a real juggling act. That's because electricity has to stay in balance at every moment. Unlike water or gas, which can sit in pipes or storage tanks for a while, electricity can't just wait in the cables. The amount we generate and amount we use have to match in real time. So here's one smart fix. Store that electricity when it's abundant. For example, in batteries. Then you can use it locally when there's less renewable energy available or during peak hours to relieve the grid from being overloaded. That's where storage systems come in. These can range from a home battery system to big hydrogen tanks. Picture this. It's a sunny afternoon, solar panels are cranking out electricity, and you store it. Then in the evening, when we're all cooking and charging our EVs, the system taps into that storage energy instead of overloading the grid. Now, back to the question of this video. What is system integration and why do we need it? Energy today isn't so simple anymore. We have several different types of energy: electricity, heat, hydrogen, battery storage, solar, wind. While each of these work to provide renewable energy, they need to work together if we are to address the challenges around grid overloading, reliability, and affordability. Here's a fun metaphor. The energy system is like an orchestra. Each element, solar panels, wind turbines, batteries, are an instrument. With no conductor and orchestration, it's noise. With a conductor, it becomes music. And that's what system integration is. To understand how this works in practice, let's travel over to Gautam for an expert explanation.
That conductor is called an energy management system, or EMS for short. Think of it as a smart control that keeps an eye on all the energy devices in a building or neighborhood: solar panels, batteries, heat pumps, and electric cars. It decides simple questions like, should we use the solar power right now? Should we store it in a battery for later? Or should we send it somewhere else where it's needed? By making these decisions at the right moment, the system helps use energy in the smartest way. Now imagine that many of these smart controllers are connected together. Homes, businesses, and neighborhood systems can now coordinate how they use and share energy. When you connect them together, you get what we call as an energy hub. In an energy hub, local renewable energy like solar can be balanced with local demand, Energy can be stored, shared, or shifted in time so we don't overload the electricity grid. In other words, instead of every building acting alone, the whole neighborhood starts working together as one smart energy hub.
Sounds simple enough? Well, the reality is actually quite complex. That's why system integration comes with big challenges: technical, social, economic, and even spatial. In our next video, we'll dive into those challenges and explore what it really takes to make system integration a reality, and we'll introduce the FlexiNet project as a case study. Stay tuned!